Hi everyone, welcome to our chemistry question and solution session. So today we'll be touching on the second question of chemical bonding. This question is on simple molecular structure and its properties. So let's take a look at the question. In 1985, a molecular form of carbon, C60, called Buckminsterfullerene, was discovered in the products formed when graphite was vaporized. The structure proposed for the molecule is a roughly spherical collection of atoms in the shape of hexagons and pentagons, very much like a soccer ball. Which of the following properties is expected of Buckminsterfullerene? Number one, it dissolves in various organic solvents. So over here, let's take a look at what is the structure. So Buckminsterfullerene has a simple covalent structure. Some people are very surprised because most people will think that, oh hey, this looks like giant covalent structure. However, take note, it's not. How do you know? The biggest hint will be the formula. So the formula for this Buckminsterfullerene is C60. Do you remember what's the formula for diamond and graphite? It's just C. Correct? So this is because when it has a giant covalent structure, the structure is a 3D network of atoms that is continuous. Okay, so over here for our Buckminsterfullerene, it's not continuous, it ends at 60 atoms. So that's why it is a molecule. So since it's a molecule, it has a simple covalent structure. So since it consists only of carbon, it contains only ID-ID interactions between molecules. Okay, so given that it has only ID-ID interactions, it can definitely dissolve in organic solvents because within organic solvents is also ID-ID interactions. Well, sometimes you have PD-PD, but predominantly ID-ID. So since they are similar, do you remember the general rule for solubility? Like dissolves like. Therefore, it will be able to dissolve in organic solvents. Number two, it contains delocalized electrons. So let's take a look. It consists of pentagons and hexagons. Let's take a look at the pentagon. One carbon atom is bonded to 3 other carbon atoms. So therefore, carbon has 4 valence electrons. 3 are used for bonding. 1 is not. So therefore, that remaining 1 valence electron is free to be delocalized around the structure. For the pentagon, let's take a look at the hexagon. So in the hexagon, 1 carbon atom is also bonded to 3 other carbon atoms. So therefore, same story, it will also contain delocalized electrons. So therefore, this is accurate. Number 3, it can conduct electricity. Now, a lot of people will think that because it contains delocalized electrons, therefore it can conduct electricity. Take note that this is wrong. Okay. It is the case for graphite. Why? Because the structure of graphite is different. The structure of graphite is layers of sheets. Okay, so it's sheets and sheets of carbon atoms organized in the hexagon. Whereas over here, my Buckminsterfullerene, it is a spherical structure. So while it can conduct electricity within this spherical structure, it cannot jump to another Buckminsterfullerene molecule next to it. Correct? So therefore, since it cannot jump to another Buckminsterfullerene, then it cannot conduct electricity. Because the idea is that you have to be able to conduct electricity throughout the molecules. So hence, it is out. Therefore, answer is just 1 and 2 only. Okay, hope that you all understand that and hope that it's useful for you. Have a nice day. Bye-bye.